Hey guys, welcome back to Simplifying Radicals. Now we're going to talk about what happens when we have variables involved in underneath the radicand. So in our first example, we've got, well, before we start, let's just look at if I had underneath the radicand something simple. If I had x to the third power, and then I had y squared, and then I had z to the fifth power. Okay, and in this case the index here is 2, so I'm looking for all my pairs that I have underneath. If I looked at x, I would write out 3 x's. Okay, then I'd have 2 y's, and I could have 5 z's. Okay, and I'm multiplying them all together. 4, 5. Okay, because my index is 2, I'm looking for my pairs. So what comes outside of the radical would be I have 1 pair of x's, and I have 1 left over. Okay, how many pairs of y's do I have? I have 1 pair of y, okay, and I have 0 left over. How about my z's? I've got z and then z, so I've got 2 z's. So it would be z squared with 1 left over. So it would look like this, xy, z squared, and that's the square root of xz. Okay, so with that in mind, looking at the first example, we've got 9 times 8. We're going to take the coefficient piece now. It gets a little more difficult because we've got the coefficient. The 9 would be 3 times 3, and the 8 would be 4 times 2. Okay, I'm just doing the prime factorization here. So 3 times 3, and then I've got 2 times 2 for my 4. Okay, so since my index is 3, I'm looking for my triples. So if I look at that, I've got 3 2's, so the 2 would go on the outside of the radical. My radical has a 3, and then I had 2 3's left over, so inside we would have a 9. Okay, so then now let's look at the variables. If I write my variables out, I've got x to the 4th power, so I'm looking for my triples. We've got 1 set of triples of x's with 1 left over, and then for my y, we've got 3, so we've got 1 set of triples, and we've got none left over. So if we put it all together, it would look like this. 2xy cube root of 9x. And that would be in simplest radical form. Okay, if I looked at the next example, this 6 on the outside means 6 times what's underneath the radicand after we simplify it. So just think of this and save this for later. Okay, because we're going to multiply that in later. We're just going to work with what's underneath the radicand right now, which is 450. Now there's no index here, so it means the index is 2. We're looking for the square root. So I'm going to start out, and I'm going to start maybe 45 and 10. Okay, then I've got 9 and 5. Then I've got 3 and 3. Okay, for 10, I've got my 5 and a 2. So we've got our prime factorization done. All right, we're looking for all of our doubles or pairs, okay, because our index is 2. So remember at the end, oops, let's give ourselves a little space here. Okay, so underneath the radical, or outside of the radical, we're looking for our pairs. So we've got this set of 3, all right, and then we've got a set of 5. Okay, through 3 times 5, and then underneath the radicand here, we have a leftover 2. Okay, we're going to look at x squared and y. So we've got x squared, 2 x's, so that would come out here, and then we've got 1 y, so that would be left over inside. Now that 6 comes down, and it gets multiplied by it. So now we multiply all of the numbers together, and when we do that, we get 18 times, we get 18 times 5, which is going to be 80. Alright, that's 80, and then what's underneath the radical would be the 2 and the y. So that would be it in simplest radical form. Okay, now looking here, the next one. Okay, a negative 2 on the outside, and our index is 3. Okay, let's make some space here. Okay, so I'm going to look at the 120, the coefficient. I'm going to say 12 times 10. Then I've got 6 times 2. There's 2 is prime. Then I've got 3 times 2. Those are all prime. For 10, 5, and 2. So once I have the prime factorization here, okay, again, now we have a negative 2 on the outside, so that's going to be multiplied at the end. Don't forget about it. Okay, we're looking, because our index is 3. I kind of wrote over that, but our index is 3, so we're looking for our triples. So if I look at my triples here, I've got 1, 2, 3. There's a 2, so 2 is going to go on the outside. All right, and then we've got 5 and 3 left over, so that's going to go on the inside. It's going to be 15 inside the radicand. Okay, my index is 3, don't forget that. All right, and then I'm going to look at the variables. I got 5 x's. So I've got to find how many triples. There's a triple, so that's x. And then I have 2 left over, so that would be x squared. And then I have to take the negative 2 and multiply by it. Okay, so at the end, this is going to become negative 4. Oops, let's do this. Negative 4x, okay, cube root of 15x squared. Okay. All right, so, okay, whoops, I made a mistake here. I forgot we were actually looking for our 2's, so let's do this. Okay, so we've got y to the third, so it's 3. We've got our 3 y's, and we're looking, our index is 2, so we've got 1 y with 1 left over. So now if I multiply everything, we're going to end up with a final answer of negative 14 x squared y radical 21y. Oh, 42y. I'm making mistakes here. Okay, sorry, 42y. And I'll circle that. Okay, looking at number 5. All right, again, the 4 is on the outside, so we're going to multiply it at the end. Okay, nice small coefficient, 4 and 3. Then we've got 2 and 2, so our prime factorization looks like this. We're looking for our pairs, so our 4 gets multiplied by our 1 pair of 2's, and then let's look at our x's. We've got 3 x's, so we've got 1 pair, and then we've got, let's see what's left over. So our 2's, we had a 3 left over, and then we had 1 x, and then our y. Okay, when we multiply, we get 8x radical 3xy. All right, number 6, 5 on the outside, so we're going to multiply that later. Our index is 3. I just wrote that over that by accident. We've got 7 times 8. Okay, I'm going to circle my 7. My 8 is 4 times 2. 4 is 2 times 2. Okay, so there's my prime factorization. So I'm looking for my triples. So I've got 1, well, we're multiplying the 5 times my triples would be, there's my 3 2's. And then for my x's, okay, we've got 8 of them. 2, 3, 4, 5, 6, 7, 8. And we're looking for triples. So, whoops, where did I go? Come back. Okay, we've got 1 set of triples, 2 set of triples. So x would be squared for the 2 sets of triples. And then left over, we've got our radical, which is going to be 3. Okay, and inside that we've got the 7, and then we've got 2 x's left over, so x squared. So if we multiply everything, we're going to get 10x squared, and it's a cube root, okay, of 7x squared. There's our answer. Okay, I'll just finish up the last 3. Okay, or just the next 3. We'll do these. Okay, so if I look at the square root of 49, go to do the prime factorization, it's just 7 times 7. So the index here is 2. So on the outside of the radical, we've got 11, okay, because we're bringing that down, times 1 pair of 7's, because the square root of 49 is 7. And then on the inside of the radical, we're going to take our 6 x's, okay, and group them in groups of 2. And you find we have 3 of them, so x will be to the third. Okay, there's nothing that's actually going to be under the radicand, so when we multiply this out, the answer is just 77x to the third, and we don't even need to have a radical sign. Okay, all right, number 8. Okay, on the outside we have a negative 3, so multiply that. Okay, here we have 9 times 2, and then 3 times 3. Okay, so if we're looking for our doubles, we've got 1 pair of 3's on the outside of the radical. On the inside, we then have a leftover 2. Okay, 8 to the 5th, 1, 2, 3, 4, 5. We're looking for our groups of 2. So this would be, we've got 1, 2, so A would be squared with the leftover A. And then for B's, we've got 2 B's, so we just have one group of B. So when we multiply out, we end up with negative 9A squared B radical 2A. Okay, whoops, I did that again. All right, moving on to number 9. Okay, 27, we've got 3 times 9, and we've got 3 times 3. Okay, this 2 on the outside is going to get multiplied later. Okay, so we're looking for our index is 2, so we're looking for our pairs. So this 2 gets multiplied by 3, because we've got one set of 3's. Okay, and then for our x's, we've got 1, 2, 3. We're looking for one pair of x's. All right, because our index is 2. And what's left over on the inside would be, we've got this 1, 3 that's left over, and actually we don't have any because we're looking for our triples. I forgot. This is actually, I wrote over it, but the index is 3. So actually, let me go back to this. Okay, so it's the cube root, so this is going to be 2 times, we got one group of 3, triple of 3's. Okay, then our x's, okay, we would have one group of x's, and then for our w's, we've got 9, 4, 5, 6, 7, 8, 9. Just divided by 3, you're going to find out you have 3 groups. Okay, so then your w would be to the 3rd power. So our final answer, there's no radical again, would be 6xw to the 3rd power. Okay. All right, so I want you guys to go ahead and try 10, 11, 12 and compare it to the answers on the answer sheet that is found on the class website. Thanks.